Okay, so just before we start the next topic, there's a couple of tricky ones for the last one, yes?
Yes, sir.
Just here for the next class. Who is this? Here for second class. Now, and which were the tricky ones now that you wanted to see from number one last time?
That's please.
Susan.
Flex.
Just the Z, yeah? Okay. So that was the one with the square root, was it?
Yes.
Yes. But the last one. Okay. Look up. That's right. Where are you for physics? Yeah.
Yeah. He starts doubting himself.
I just like freaking people out with that. All right. Y equals square root x. So this one was a bit tricky to do from first principles. It would be unlikely for the exam, very unlikely, because it's quite difficult, but it's not impossible. So we'll have a look at that now.
Something like that was last year.
Huh?
Something like that was last year.
No, it was x squared last year.
There are lots of versions.
I know, but just one of them had x squared in it. I know, I wrote that one.
Oh, it wasn't perfect. It wasn't perfect.
Oh, for other maths you have first principles.
Not perfect. We had to find the. We had to differentiate the complicated function.
Ah, and there was a square root.
Was
Okay. Now here we have dy dx equals, so we know the rule, square root x plus h minus square root x all over h. Now, what we need to do here to try and simplify it is to multiply the top and the bottom by the conjugate. So what I'll do here is multiply the top by root x plus h plus root x, and multiply the bottom by root x plus h plus root x. So when I multiply the top, I'll get root x plus h times root x plus h, which is x plus h, and then you'll end up getting minus root x times root x plus h plus root x times root x plus h minus x. And then on the bottom you'll just get h root x plus h root x. The middle two cancel, and actually more than just the middle two. In fact, the x's cancel as well. So we have now on the top h. In fact, I don't think I should have multiplied the h in at the bottom, because if I leave it out, I can do some cancelling. I'm just going to wait until we're all listening. Yes? So we have h on the top, and then h bracket root x plus h plus root x.
shouldn't be.
They cancel.
Yeah.
And that leaves me with 1 over root x plus h plus root x. Okay. Now that I've fully simplified it, I should make the h go to 0. So if I make the h go to... Did I want the h going to 0 or not in the first one? No, so I should really stop there. I don't know if I actually did in the back. Did I? Wait, which one am I looking at? Last one. Yeah, no, I did stop there at the back. So that's the answer. Delta y delta x equals 1 over root x plus h plus root x. And if I wanted the limit, I make h go to 0, it'd be 1 over root x plus root x. So 1 over 2 root x will be the answer then. Okay, so write that down, please. Question, Joshua? No?
This is for one.
The last one in number 1 on page 84.
Is that 1 over square root of x?
Oh, it is. Yes, this is the answer here. I'm saying if we wanted the derivative, that would be it there. But no, this is the answer here, yes. What's wrong? Are you sure? Don't believe you. All right. Is there anything else on that page, so? Just that one was tricky? Yeah. Okay, so we can go on. I would think that there should be no problems really in 84, except actually 1D. I would like everybody to do 1D for me on page 84. Yeah. See what you get. Yeah. No, not that. Come on, guys. 1D. The log one. I want everybody to try and give me the derivative here. Log 4x power 5. Okay, do we have any answers yet? So what do we have as the answer?
5 over x.
You have 5 over x? Yeah? 5 over? 5 over 4?
Not 5 over 4x. Because x.
5 down, then the derivative of 4x is 4, then the derivative of 4 is 1 over.
You have x power. Derivative of x is 1. X power.
I got 5 over 4x.
You got the x. Which one did you do first?
Yes, but she's fully figured it out now. No, I'll do it now. I want this. Look, what I wanted to see here is if anybody would make the mistake. Listen. What I wanted to see here is if anybody would make the mistake of saying it's 1 over 4x5. It's not that, okay? If you look at the formulas I gave, what's the derivative of log x? 1 over x. That's log x, and it must be log x. It can't be log 4x power 5. So the first problem is that it's not written ready for the formula book. So we just have to use 2 of our rules for log. We'll use the first rule of log, which says y equals log 4 plus log x5. And then the fourth rule of logs that says you can bring the power down. Now when you look at this, the situation is constant plus constant by log x. So the derivative here is going to be 0 plus 5 times 1 over x. So in other words, 5 over x is the answer.
Yep.
Can't we just, when we do that, take the 4 and 5, put it in the numerator, and leave the 4.
We haven't done that rule yet.
But is it like that?
That's called the chain rule, which is in semester 2. It is correct, but you shouldn't be using rules from semester 2 because that's not what they want you to do for the exam. Not that it's wrong, but it could be that you're missing something that they might be looking for in a later part that you would have skipped over, you know. Yes?
Was it given the second step?
Here? How did I get this one? How did I get this one? First rule of logs. Log xy equals log x plus log y. Remember your log rules? I'm sorry, when a student smiles at me like that, I know the answer is no. I don't remember. So if you forgot them, you need to review them, okay? Alright, I just wanted to point that one out because I've seen it once or twice in the exam and it catches students out sometimes. Okay, so just take care with the log. It is not 1 over 4x5. It's a pretty common mistake for students to make, so take care with that. You need to simplify with the log rules first. Okay? Right, so we'll go on to the next section now. So page 86. Okay, for example, let me actually graph that as well. Right, while the program's loading, I would like everybody to find the minimum point by using the method of completing the squares. So I want everyone to give me the minimum point here. So if we use the turning point, what's wrong, Joshua? Well, I'm going to do it now. So if we use the completing the square method, we get y equals x plus 2 squared plus 5. Yes? So the minimum will be where? Minus 2 and 5. And if I graph that, I can see it as well. X squared plus 4x plus 9. Graph and graph. Let's zoom out a bit. Okay, so you can see there it is there at minus 2 and 5. But what you'll notice, which I was mentioning last day as well, is that if I draw the tangent line here, so let's say tangent of this equation when x is minus 2, if I draw this tangent line, it's horizontal, perfectly horizontal. That means that the slope of the tangent is 0. And this gives us another way of finding the turning point. What we could do instead is we could find when the tangent has no slope. So what is the derivative here? 2x plus 4 equals 0. So what would x equal? Minus 2. Same answer, isn't it? And then if I put minus 2 back in for my y, put minus 2 back in, I'll get y equals 5, which is also the same. So this is how we can find what's called turning points. We just need to solve for when dy dx equals 0. So we'll make note of that. To find the turning points,
Can we just call it tangent? Can we call it tangent?
not quite, because it's not quite tangent. To find the turning points, we need to solve dy dx equals 0. There are so many words that mean turning point. You might actually know some already. Turning point, yeah, critical point, vertex is also turning point. Think more maths. You're thinking 2 EAP. Think more maths. Turning point, stationary point, critical point, vertex, max or min?
Extreme.
Yeah. Extreme, yes. Yeah. And there's probably many more. So in the worksheet I tried to use as many as I could think of. But in the exam they prefer the word turning point, which is what I just used, or stationary point. And the reason they call it stationary point is because if you look at the graph, it's where the graph is not really changing, because it's kind of nearly flat here. It changes a lot here. It's going down, it's going up, but here it's flat, roughly. So this is why we call it stationary point. It's like it's standing still at this point. It's not moving much, okay? So to find the turning point, we just need to find when dy dx is 0. So let's have a look at some more examples, maybe a little bit more difficult. Okay, so for example, let's see what we've got. We want a cubic one now. So y equals 2x cubed minus 18x squared. This is the first one here. 54x plus 30. 2x cubed. Okay, so here in this example, to find the turning point, I need to find the derivative, which will be 6x squared minus 36x plus 54, and you want to know when it equals 0. All these numbers can be divided by 6. So what do I get here for the answer? A 3 and a 3?
Yeah.
So x equals 3. So please substitute that back in and tell me what the y is.
Substitute in the very first one.
The very first one, yes. Did you do that, Joshua? 84, yeah?
Yeah.
Okay. And let me graph this now. So the graph, I have 2x cubed minus 18x squared plus 54x plus 30. Where did we say the turning point was? 84. What was it, the x?
84.
So we'll need to go quite high on the vertical. There we go. So if I graph this now, yeah, there you can see it there, kind of. Not quite there. Maybe. Yeah, you can kind of see it there, 384, that's it there. It's pretty flat, nearly flat. I mean, it's not going to be flat. Now, if I draw the tangent line here, something interesting happens. Graph. Not really, no. Now, this crosses the line here, but I said it crosses it only once for tangent line. But what's happening here is you could try and imagine situations where the line touches once, but then it would cut the curve again later, maybe if it comes back up here, as an example. Okay, so I'll try and give you an example where I can think of where that might happen. Might have to be something with sine. Okay, so let's say sine x. Okay. I want to try, oh, I know. We'll make the sine x get bigger. Okay. Right, there we go. So if I draw a tangent at, let's say, this point here, 3, tangent when x is 3, now we got it there. Now look, there's the tangent at 3. But you see how it cuts the curve again much later down here. Is it right or wrong to call this a tangent? It's still right to call this a tangent, okay? Yes, so we need to extend the definition. So I didn't want to give you too much at the start. So when we say a tangent touches the curve only once, what we really mean to say is it touches the curve only once locally. So you don't count any time it meets much later. Okay? So a tangent touches the curve once locally. So this is still considered a tangent, even though it cuts it later here. So that is introducing the word of local, which is important for these graphs. When they say local, they mean, just like in English, local, nearby. Okay? So please make note of that somewhere. A tangent, if you wrote down the definition of tangent, you can just now add in the word local if you have it. Or just make some note of that. Okay. Right, now let's do some more difficult examples. Okay, so let's do one with a log in it now, like C. Can I scroll down from here? So for example, y equals log x power 18 minus 1x squared minus 16x minus 2. Before I even start, I should rewrite this as 18 log x minus x squared minus 16x minus 2. Now I can differentiate. I get 18 over x minus 2x minus 16 minus 2. Sorry, not minus 2, of course. Minus 16. To find the turning point, we want to know when that's 0. So we end up trying to solve this equation. 18 over x minus 2x minus 16 equals 0. So how can we solve this? We've actually seen this, I think, twice before now. What do we do to solve this? Yeah, multiply everything by x. And the moment you do that, you need to specify that x cannot be 0. We're not allowed to do this if x is 0. So if we get x as 0 as the answer, we have to investigate further. There might be some problem, but I don't think it will happen here. So we get 18 minus 2x squared minus 16x equals 0. So I get 2x squared plus 16x minus 18 equals 0. So I get x squared plus 8x minus 9 equals 0. And I have two answers. What did you say, sorry?
X minus 9.
Are you giving me this part? Yes. So then you get two answers here. X equals 1 or minus 9. Now I'll just skip this part here because that's not important right now. Just put the x back in to get the y. But what's more important is this question. Can we use both of these answers for x? Or is there something we need to be careful about?
It doesn't equal 0. X doesn't equal 0.
No, that's not. Well, that's true, but it's not 0, so it's fine. And what were you saying? So you're saying we can't use the minus answer?
Yes.
No, but we can. So she said, which is right, you shouldn't use the minus answer.
We have power 18.
Exactly. You shouldn't use the minus answer because it's log. But if you look carefully at the original, you see it's not log. It's log power 18. If x was negative, what happens when you put it to a power 18? It's positive. So this number, in fact, is always positive. The only number that we're not allowed to use here is what? We can't use 0, that's right. And that's good, because later in the question I said, well, we can multiply both sides by x if x is not 0. So that's actually a good situation to be in. So both of these answers are fine. We can sub it back in to get the y. I won't bother. It's just going to be some decimal number here.
Do we use the same both numbers or just pick
We
one?
use both. Both are accepted. Yes. Now I'll graph it because there's two answers, so we can see what the graph looks like here. What is it? Sorry. Log x power 18. What's next?
Minus x squared
Minus x squared
minus 16x
minus 16x
minus 2.
minus 2. Okay. So this had two turning points. Let's have a look at them. Reset. Okay, now let's zoom out, I'd say. Too far. And oops, this way. Oh dear. There we go. So you can see the two turning points, kind of funny shaped graph. It increases, this is the first turning point, and then it decreases, and then increases again, and this is the second turning point. Now, this graph is actually very important because later we're going to be talking about maximum and minimums. And sometimes, listen. So later we're going to be talking about which is the maximum and which is the minimum. And a lot of the students just say, oh, that's easy. Because if I have a graph, like a cubic, the value of y that's bigger is the max because that's the top. And then the value of y at the bottom, that's the minimum because it's the one at the bottom. So it's easy to tell which is the max and which is the min. You just look at the y. Big Y means it's the max and small y means it's the min. But this is not true. And here's an example that shows this. If you look at this graph, the big Y is a max. It's a hill, isn't it? But the smaller Y value, the negative Y value, is also a max. So this graph actually has two maximums. One of them is absolute true and one of them is local. You're right. But still, it makes the point. So at some point when we're doing the second derivative, which tells us how to find the max and the min, somebody might ask, can't we just look at the y? And that is true sometimes, but not all the time. And here's an example that shows when it's not true. Okay? And you might say, well, my formula found two maximums, but it didn't find the minimum. Because it looks like there's a minimum there. Isn't there? Where does the minimum look like it is? So it seems to be around about here, isn't it? Yeah, so let's zoom in there and see what it is. Center on cross and zoom in. Alright, so where would you say the minimum is at? Minus 70. Okay, so let's zoom in to get an exact answer. Center on cross. Where's center on cross? Here it is. No. There we go. Okay, let's zoom in a bit more. Alright, where do you think the minimum is now?
84.
Minus 85, okay.
It goes to infinity.
Yeah, it's going down to minus infinity. So as we try to look closer and closer, we can't actually find the minimum. And the reason is, there is no minimum because in this original graph here, it looks like it stops here. It doesn't. In fact, it goes down to minus infinity. It's just not, you're not able to see it here because it's running along the y-axis. Okay? So there is no minimum here. And besides, even if this was a minimum here, we cannot use it because remember, originally we said x is not allowed to be 0. Okay? Right, I'll give you one to try now. Right. I want you to try this one for me, please. Y equals, let me think. Okay, so 9 over 2 e power 2x minus 3ex minus 6x plus 1. Right. I want you to find the turning points for this. Once you write it down, I'll draw the graph as well for you. So, what do we do? Derivative equals 0. So try that for me. Question? Yes, yeah. Did you write that down? Because I want to graph it. So, Naveed, if you don't mind now reading it back to me. 9 over 2
e to the power 2x
2x
minus 3 e to the power x
yeah oops e to the power of x
minus 6x
minus 6x. Well, doesn't actually change it too much because when you differentiate it, it goes.
Yeah, here it remains 2.
Guys, as you're doing the question, if you want, there's the graph of it. So you can see from the graph that your answer should be, somewhere between 0 and 1, I'd say. The x looks like it should be maybe between minus 1 and 1. So it should be as small. Yeah. Yeah.
Move this one to the right.
Yeah, that's right.
But it stays here.
Correct, yes.
Still?
It does. It does indeed. Huh?
Do you have to take a length here? No.
There might be more than one answer. Depends on how good my graph was. If I zoomed out enough. No, it's not blue balls. Well, what answer did you get? The one could possibly be right. And so minus one if I assume the right level on my graph.
Unix is 0.
But both answers
So
can be used.
you
Yeah.
have that yes
Yeah.
0. Sub it. Get the values.
Let me see what it is.
Yeah, but now we have to find x.
Oh, yeah, but you forgot those are easy, aren't they?
No, this is e to the power of x equals 1. We can find x. So,
Nearly there, yeah. I just want to do it now. Yes, this is not the derivative of these. You're thinking of log. Look at your table book.
I guess I have to find that. E to the power of x equals 1.
Don't reject that.
So just
Okay, let's have a look at the answer now. So we differentiate. The 2 comes down and cancels the 2. So I have 9e2x. Yep. Minus 3ex minus 6 equals 0. Divide everything by 3. 2e2x minus ex, sorry. Divide everything by 3. 3e2x minus ex minus 2 equals 0. Does this have roots, or do you need to use the formula? It does.
0 and minus 2 over 3.
Yeah, 3ex, ex, 2, 1, and I need a minus 3, so minus and plus like that.
Why is it minus 1? The root is 0, not 1. 1 over the root. Oh no, it's 1. Sorry, 0. Yeah.
Yes?
How do we get the answer?
This? I factorized. I'm sorry, what does this mean? I'm not finished yet. I'm not finished yet. I just up to here. We're okay?
How do we factorize it?
How did I factorize? We had a whole 1 hour factorizing. Do you remember? So you're looking for numbers that multiply to make 3 at the front. So 3 and 1. 3 and 1 multiply to make 3, yes?
What's considered to be that?
The ex is considered to be the x. Yeah. Yeah. So it's like 3x squared minus x minus 2.
Yeah.
Okay. If you're not happy with that, you can just use the quadratic formula. Yeah, we have some more to do.
2x.
Charles!
How do you get 2x out of it? Wouldn't that be 3ex squared?
No, this is right. This is right. Okay. So here, are we paying attention? So here I have 2 answers to consider. The first one, 3ex plus 2 equals 0, or ex minus 1 equals 0. So here I get ex equals minus 2 over 3, or ex equals 1. Now the way we cancel an e is by using log. So here we put log on both sides. But now you see there's a problem straight away. You can't have log of a negative number. In fact, e can not be negative, so you can never have this as 0. So this answer you reject. The second answer you get x equals 0. So yeah, it was actually nearer to 0 than I thought. It was 0. X is 0, we can put that back in to get the y.
5 over 2.
What is it?
5 over 2.
5 over 2. Okay. 5 over 2. So the point is 0, 5 over 2. Let's have a look at that on the graph. I'll put this back in a minute, don't worry. So it actually turns out here is the minimum. So I maybe should zoom in a little bit here. Yeah, you can kind of, when you zoom in more, you can see that the 0 is at the lowest point, and it does look to be at 2.5. Exactly 2.5. Yeah. Yes. You're right, what's wrong? Sorry, you need the maths back. Okay, write that down. Okay, did you write that down now? Oh, Joshua, do you want to go upstairs and see the laptops there? Oh, that's his one.
Found it.
Right. Okay. So let me tell you which ones I'd like you to try. Listen. So the ones I want you to try, let's see, we can do a quadratic, so that's number 4. And then a cubic, that's number 8. And then a log, that's number 9. And then the last two with the sine and the e, so 27 and 28. So it is 4, 8, 9, 27, 28. So you probably should get them finished now. So I want you to start working on them now, okay?
Yes, sir.
Yes, 1 second.
4, 8,